I want this next, whatever it is, 50 minutes to be as relaxed as possible. I've got a few subjects that I'm going to touch on, and but if anybody wants to stop me, ask any questions, we want to go in different directions, then please feel free. All right. Again, I want this to be a bit two-way, so maybe we'll do a bit of audience participation as we go through this. So, to start with, I thought I'd just throw this in, and this is probably just to test the age of some of you in here. We've got all ages from what I can see. Does anybody know what this is?
Lawnmower.
No, not quite.
Silent computer?
Nope.
First display.
This was the first piece of precision farming that John Deere brought to market. Have a guess when this came into when we launched this.
1985.
Close. It was 1998. So 1998, that was when John Deere started with precision farming. And this was what we call the old brown box. That recorded data or yield data. Didn't tell you where any of that yield came from. Was it from a field? But that was the original brown box. And you had a screen, which was pretty dumb. You had a processor, and then you had to take some big old lumpy memory cards in the top to actually get anything out of it. So it's come a long way, hasn't it, really, from where stuff is today. And I guess that today is the modern day equivalent. So, you know, that is the brains of everything we do, precision farming wise. Probably cost, that was probably twice as expensive as that at the time. And, you know, today, and we'll talk on some of the stuff as you go through this, everything revolves around being able to process data. Also today, everything revolves around knowing where a machine is generally. And having a little gun out, I mean, I think I need a bit of it weighs a ton. That was our original Starfire receiver. So again, clues on the board. We introduced that 20 years ago. So the first actual auto tractor from John Deere was in 2002, and it had a big old lumpy receiver like that on the top of it. Today it looks like that, and next year it will look like that. So that's the new one that was accurate to about God knows how far from here to you, probably away. And today, you know, it's sub-inch, it's centimeters, got everything in it, you know, deals with lots of different connection signals, tells you where it is in the world, etc. So again, probably just putting into perspective really where technology is coming. And I know when I was here sat where you are, I think I only just had a mobile phone, you know, and it was a great big brick of a thing. And I didn't have a sat nav and I didn't have any of that. But today, of course, modern agricultural machinery has all of this stuff, and most of it is standard equipment. So that's the evolution of where things are. And if we go through a few more slides, I want to really just talk on a couple of key subjects and maybe where some of all this technology fits, and that's electrification, site-specific farming, and autonomy. So I'm going to touch on those three subjects. All right. Any questions so far? Good. All right. So, bit of a topical subject. What we're going to drive all these machines with. What's the future? What's the future power source of a modern day vehicle? What do you reckon? Okay. What else? Yeah. Yeah. Well, it's as if you've seen my slides. So we get asked an awful lot of where is John Deere's focus, where are we working on as far as our future propulsion for vehicles. And, you know, if you can look at some pretty simple basic numbers, probably you in here probably see these or analyze these in far greater depth than what I've got on here. So, you know, diesel today, from what you've got in the tank, if we take that as a reference, you know, 100% of the power comes from the diesel that's available from you. If you went to some type of biofuel, then you're probably only going to lose a little bit of your power density of that vehicle. Okay. If you go to methane, you're going to lose an awful lot. So if your fuel tank today is going to give you, let's make the maths easy, 10 hours of work, then with the equivalent amount of methane, you're probably only get just over 2 hours out of that vehicle. If you go to hydrogen, it's just over an hour. So again, you can see this adds huge amounts of complexity for people like us when we're designing and developing vehicles. You know, where does that take the design life or the design scale of the machine? And actually, if you look at battery, again, it's just over an hour worth of work on the equivalent vehicle size. So again, these are all very different complexities that our engineers are having to deal with in how they design and develop future vehicles, and the considerations of what each one of those power sources may have on the envelope of the machine. If you look at the CO2 sort of offset that each one would have, so we like to say that diesel is all bad fossil fuel, so that's 0. If you go to something like rapeseed, there is the possibility to have very renewable biofuels available to you. So again, you can offset an awful lot of your CO2. Methane, again, good for CO2. Hydrogen, maybe not so good. And then battery, of course, when we've got green energy available to us, whether that be solar, wind, or whatever it might be, to generate electricity, then we can get an awful lot of offset. So I guess the question is, what should we work on? What's the best one? Looking at all that, what's the best one? Absolutely. Absolutely.
How can you say it's 100% for the CO2 when actually, if you take into consideration the recycling of the batteries after their life?
Yeah, well, maybe that's just a little bit of a grey area. Yeah, we won't necessarily just touch purely on that. So, yes, yeah, absolutely. If you take the envelope that you have today, so I guess there is no right or wrong answer to that. And I think, you know, as far as Deere is concerned, we're working on all of them. So, you know, if we know there are some manufacturers that have gone a particular route and they've publicized and that's a direction of travel, we are not at that point to really define specifically what our final solution will be. And I think to your point, there will be probably a mixture of all of these in the vehicles that you will see from John Deere in the future. You know, that is most likely to happen. Depending on the application, there's an application, there's a reason for all. What I would say is we've done quite a lot of playing around with batteries. So even 10 years ago, there was this battery powered tractor that was knocking around, and actually battery does offer some huge advantages. You can read those quicker than me, hopefully up there on the screen. So, you know, that is probably something that we're looking at quite closely. If you look at the power density that you get from the power source, pardon? You didn't have weight on that chart, no. Again, we'll maybe get onto that in a second. Yeah. So, you know, as far as actually where you get power and the power density from electric motors, again, they are hugely efficient, great power density. So, you know, the physical size for what you get out is pretty clever, really. And what I would say is you know, quite a bold statement from John Deere is that we've actually committed the use of electric drive or electrification. We've actually been using it for quite some time in a lot of our construction machines. We've had a lot of hybrid type vehicles, and we've actually committed that by 2026 we will have a fully autonomous battery vehicle available for the ag industry. What size that will be, it's probably going to be on the smaller scale compared to maybe that full range. So, you know, it may be 100 horsepower type size vehicle. It's probably not going to be a 9R or 9RX type vehicle, because again, to the weight of where your batteries required for the duty cycle, we're just not there as far as ability. Battery is going to be part of what we do, and of course, you know, in maybe the smaller commercial grounds care, lawn care type applications, battery will be significantly easier to install in a lot of those vehicles. So again, that will be part of our strategy, and we will continue to expand our hybrid vehicles, specifically in construction vehicles as well. So, you know, battery is well and truly on the horizon. But going back to my previous slide, you know, nothing is off the table, but right now battery probably will give us some quick wins in some of the product development that we're working on. And probably a bit of a clue, if those of you that stay on top of a lot of the John Deere news in the press, is that we bought a battery company. So Kreisel is an Austrian company, and they specialize in batteries, but also the technology around charging. So it's given us probably a head start to where we need to be. And there's a few little graphics up there that talk about, you know, the development of batteries over the next 30 years or so. You know, it's going to continue to develop. We're going to get more capacity out. We're going to see big reductions in cost of batteries as well. We probably don't see there's going to be much more efficiency drives, but you know, I think the industries will work around what the capability of battery vehicles are. Again, you know, we are being driven by a lot of our customer base. I made this comment to David earlier. You know, we've got customers that have a greening requirement for battery vehicles, and they want to go and be able to prove that they're a supplier of whatever they might be doing, mainly in either local authority or high value crops, and that they're you know, to meet their greening requirement, they want battery. And you know, there'll probably be some solutions that we can offer that will be able to fix that for them in the very near future.
Can you look into part parcel of your electric solution, the charging system into the customer as well? So for a large processing plant or an ag side or whatever, you're looking to put the charging system in on their site as well as the vehicles to.
I think that's all going to be part of the solution that you offer. So that will come as part of a package. The charging technology is as important as the battery part of it. So, you know, that's where, to really get the most out of the vehicle, that's going to be important. And again, you know, the duty cycles that people will learn to accept in the future could be very different. You know, today, the thought that you fill a vehicle up first thing in the morning and it does a 10-hour day, and then you fill it up tomorrow morning, that may change based on that your demand for a green vehicle is higher than actually if I need a gap in the middle of the day to charge it, that may well be.
Expecting people to change their working methods.
It could well be. Yep.
Because you touched on the previous slide.
Yep.
Is that the same approach as a Toyota car?
Yeah, diesel generation, or it could be biofuel, diesel generator, electric drive. Again, you know, we can benefit from some efficiencies there, and most importantly, and we'll talk about it in a moment when we see what we've done in our ag vehicles, you start reducing the complexity of a vehicle, you have less moving parts, actually your durability and reliability go up by adding electric drives into vehicles. What, these London buses? Yeah. So it's even as if you've seen the slides as well. So again, anybody doesn't know Chrysler, Chrysler actually supply batteries for all the electric London buses. So you could say there's a little bit of John Deere in every one of them red buses. So that's something that's quite an interesting. He's not taking all the credit for that, is he? So I guess that's a high level look at battery. And I think, you know, the next 2-5 years are going to be pretty interesting times in the agricultural and construction and commercial equipment markets, because I think we're going to see a rapid development in products in that space. I mean, again, some of you in this room are all young, enthusiastic. Some of you might be graduating soonish, maybe. You know, if you go to the Chrysler website and if you're interested in jobs of working in battery tech, there's about 17 jobs on their website right now. So again, you know, the amount of talent that is going in to develop products of the future. So maybe that's a slightly different angle, but it probably very much fits a lot of the skill set that's in the room. So maybe you consider that. So where are we maybe right now today? Some of you again might have seen that we introduced our first sort of hybrid type ag vehicle, so our 8RX e-auto power. So again, this is where, you know, I'll skip through some of the bits of this. We take a regular auto power type transmission, an IVT transmission, but all of that complexity of motors within there, pumps and motors, you throw that out and you replace it with generator and motor, electric motor. So again, you know, where we would be driving hydraulic fluid, we're now generating electricity. We use that electric to then push back in to give us that infinitely variable transmission. So again, we remove some of the complexity, we remove some of the durability concerns that, you know, potentially high pressure pumps and motors may have. And, you know, we actually can drive some efficiency. We can bring the noise levels down of these vehicles. And, you know, another added benefit, we actually can siphon off a bit of that power. So today, you know, we can plug in, we can take roughly 80 to 100 horsepower out the back of that tractor as an electric drive, and we can drive something on the back. So at the moment, we're running around with a Joskin tanker. It's got a powered axle. It allows you to go to a bigger vehicle, put a bigger toolbar on the back. You can pull more. So again, you can have less passes on the field. You can do a better, more efficient job of what you do. So won't have the sound coming out. So again, you know, this is where you see it in your own eyes. You can have a big tractor with a big tanker on the back, pull in a big toolbar, and then as soon as you flick that offboarding power on, you then take up to 100 horsepower to help you drive through whatever it might be. Again, you have much better ground conditions. You're not churning up the soil, etc. So really a true benefit. And today, you know, I think the standards for offboarding power have now been defined. We're starting to see more and more implement manufacturers looking at using that power generation or that electric power to be able to use. So again, if you think the complexity of PTO drives, hydraulic motors and fans for whatever it might be, we can really simplify even the attachments on the back by taking electric drive into that. So that's quite an exciting time for us. You know, we're new to the market with it. We're the first one, and hopefully this will also lead to others, so that there's a park of implements that are available on the back to really get the benefit of it.
What voltage is
It is 400 and something, 420, 470, between 420 and 470. DC. Yeah. So perfect solution going forward. So my second little subject to talk about, site-specific farming. Site-specific farming, fancy word maybe for precision ag, precision farming, whatever it might be. And I guess the one thing that I would say is, you go back to this was precision farming. We could tell you how much a field yielded, but that was about it. In its later days, you could actually put a prescription in there to put a variable rate on, but it was a bit lumpy. Today, site-specific farming has gone, for us, not only the field, not only the header width of a combine, not only the boom width, but you start talking at plant-specific agronomy or control of what you do with that farming. So, and I think this is the absolutely important thing today. We've been doing precision farming for nearly 25 years. Today, there is a massive disparity across farms that what they do with that information and that data. I think for those of you that are farmers or connected directly with farmers, there's an awful lot of farmers out there today that have data and have never done anything with it. I visited a customer recently. They've been collecting cotton or yield data off the combine for 10 years, and they don't do anything with it. It's a lost opportunity, and I think never has there been a time that precision farming, site-specific farming, has become more important. So, the current situation that we have, where we've got high commodity price, high returns today, so we need to maximize what we get from the field. But of course, we've got those very high input costs that go along with it. The calculation still works. Farmers are profitable, but to make sure that going forward that we get that right mix, and depending on where legislation goes with different chemicals and the amount of even fertilizers and whatnot we can apply, we need to make sure that we're giving as much information to our customers as possible to ensure that they are absolutely maximizing the return from what they put on the field.
Why did the farmer not use the data? Was it the data was too much, too clunky, not interested, didn't need it, couldn't access it?
To a certain degree, it came back to a traditional, well, I sort of know what I'm doing. I've got an agronomist who, he's done a field walk, he's given me this recommendation, and they're using a traditional farming method.
Right. So the agronomist didn't even know that.
No, nobody wanted it. Yeah. So now that's one extreme, and there are customers that are absolutely doing, but if you looked at where the average was, it's probably a lower side of the average than it is the. Yeah. So there's lots of drivers we touched on to reduce nutrient and fertilizer runoff, etc. So there's lots and lots of pressures today for this to be more and more important. So I guess knowing what we're harvesting is a big starting point. That's the known fact, isn't it? What we're actually taking off the field, that should really drive what we put back on the field. But this has changed again quite dramatically, and I think one of our thinking would be is this isn't just about yield anymore. So, you know, there's been lots of people that have spoken that precision farming is purely about the yield that you get, and you can throw as much nitrogen on as you like to then get a greater yield. But today that's not feasible in the calculation that is there. And you know, some of the things that we're looking at is actually if we start really measuring what the yield is, and that's not only the volume that you're getting, but also the how good it is. You know, so with today, we can take our Harvest Lab sensor, so an NIR sensor, we bolt it on the side of the combine, and we can measure the protein in wheat. So, you know, you are then measuring protein, not necessarily across the whole wheat or across the field, or a trailer load that you might be doing if you're doing a lab type test at the back at the farmyard. You're doing this on a regular basis. So, what to say on there? One data point every every second, effectively, compared to what it might have been every 2 to 4 hectares if you were doing it per trailer load. So you can really start analysing the quality of what you're getting off the field. And why do you want to do this? Well, you know, actually understanding what the protein level of wheat, or actually even, you know, it will also do oil in oilseed rapes. You can start to determine what are you going to do with that. Do I put it in a pile here for milling? Do I put a pile in here for feed? Do I sell it all in a batch? Do I average it out, or do I sell this lot where I can get a really good return because it's got a high oil content? You can start making those type of agronomic or business decisions on what you're generating. Not every piece of grain is the same, and actually what you get paid per grain could be different. I'm not saying that it's happening today, but at least if you've got the right data, you can start actually making some decisions. What looks like a complicated picture there, but you know, actually yield can vary greatly, and actually yield can be completely opposite for the protein level. So a low yield could actually have a high protein and vice versa. So again, this is where with the right decisions, you can start saying, well, actually, do I want to start putting more nitrogen in that specific area to get a higher protein, or actually do I want, where do I want my protein level to be to what I'm going to sell my commodity for? So lots and lots of data that is available, and we can start really getting down to this, as you say, this site-specific farming, where we're looking more specifically at what we're taking off as the crop. And I think you know, the one thing that is absolutely crystal clear is, you know, people like us are good at machines, we're good at technology, we're good at data. You know, we've been doing that for a long time, but you know, we're not agronomists either. So you know, we will have an appreciation of what a farmer may want or not. But where we store a lot of this data in our operations centre, this is where we've got it absolutely open to anybody who wants to work with the data. Again, topical conversation. You asked the question earlier, who owns the data? Customer owns data. It's his data. So if Mr. Customer decides he wants to share it with his agronomist or some other third-party advisor, and if they've got an input and they want to give a bit of a viewpoint, then let them process it, feed it back into the John Deere Operations Centre, send it to the vehicle, all nice and wireless, and that vehicle would do whatever job it's told. So again, going back to, you know, my customer that I met the other day, you know, he's got a lot of data, there is somebody out there that can give him an awful lot of advice, whether he decides to take it or not. And actually, right now, you know, whatever it is, 280, 300 pounds a ton, whatever he's getting for his wheat that he's forward selling, you know, it doesn't take long to actually pay back some of this technology and, you know, some of this advice to be doing a better job. Yes, yeah, he's in a perfect scenario. Yeah.
How recognises the data by the growers and the markets they're after? You say it's got this much oil in it, it's got this much protein in it. How close is that to, you know, what happens in the lab?
It's pretty close. Yeah, I mean, you would be expected to do a calibration, but that would normally then last you at least, if you've got a batch of the same variety, you'd probably at least do that. You might want to do another calibration on a different variety, but it's pretty good.
And are the people who are, you know, again, customers buying it, are they recognising that data set, or are they still doing their own just to have a look?
They are, yeah. But again, the people that we've got now working with this, they're the early adopters, and they want it and they want it. So it's now convincing everybody else to say, actually, this is where it's going. Yeah. And on the same sort of subjects, I mean, I'll put this picture up. This is sort of the final picture of that. You know, site-specific farming, it is looking at everything. What's coming off? What's going on? You know, you start looking at it in a lot more granular point. The other interesting subject, I've just taken a group of journalists out to East Germany, or just near Berlin, on a big farm there, where they're using a lot of what we've already spoken about, and it's one of our test farms. And we took these journalists and and I've given almost exactly the same, or our team has given the same talk to what I've had so far with all of you. People struggle to communicate this. It's a tough subject. You know, if you're talking about, you know, engineering and whatever and machines, you talk about horsepower and lift capacity and oil flow and whatever else. You know, actually, when you start getting into, you know, really what's going to make a difference nowadays, it's really difficult to get across. And, you know, your job gets harder and harder to actually communicate some of this as well. So, yes.
Can you just explain how that reconciles with the fact that the header in your combines will be 40? And so the data you're collecting is over 40 foot back.
It would be.
You're saying that you can site-specific farm down to a meter width.
Maybe we'll come on to the next one. But yeah, you're right. That the area that
machines have got bigger, actually, the
yeah.
stage is getting less and less accurate as well.
Yeah, you're right. The width of the header for this would be the limiting factor of the area that you'd cover. But again, it's every second, so it would be a small strip. We'll go on to my next one. It's where we get to the true site-specific farming. And that's where we get into see and spray. So again, we know we've got test units here on farm, whether that be laser, whether it be whatever it might be. We've launched site see and spray as available in the US today. So you can buy that machine with cameras that will go and it will spot spray specifically. So again, that's where you then take that site specific to the very next level.
But that's totally different thing.
Yes.
You're blending two things there that are not connected.
No.
And that's a visual identification of a weed.
No, but then it could be, that's a weed type application, but it could be something else. Yeah. Yeah. So site specific, again, available from us. We will see this commercially available in the very near future within Europe. So we've got this on test. Again, most of, as you would know from the tests that you do here at the university, it's all about the applied learning. It's getting enough crop through it to actually understand what it's seeing and doing. So that's quite interesting times for us that we start seeing that. Again, massive savings on input costs that we will start to see that will benefit our customers. Okay.
Are there any differences between countries and the adoption? So you mentioned you went out to near Berlin.
Yep.
You've also got customers in the UK. You mentioned about the US.
Yep.
So is it that some countries are saying, yes, please, bring it on, and adopting this and taking the app, using it very heavily, and
yep.
7% of your customers are specific farming, and the UK is lagging behind? Or is it the way around that the UK farmer is quite open to this and is driving it forward and saying, please, we the next bit of technology, where is it? Please develop it. You know, so where's the UK in the ranking order, you might say, if it's such a thing that you can generate?
I don't know if you heard that online. Where's the ranking of the UK with the adoption of a lot of these technologies? That, good question. I wouldn't know where the UK would fit particularly. I think, like a lot of places, we have some very early adopters of a lot of precision farming, and we've got some people that are absolutely living and breathing it, and then we've got others that are a mile away. If you read some of the data, it would show that the UK agriculture, the output or the productivity is below some of our European colleagues. So could you put any of that down to precision farming adoption? I'm not sure that you can. There are certain pockets where there are definitely some focus areas, like places like the Netherlands is a particular hotspot. You know, today, as far as like our NIR sensor, you know, with a lot of what's going on in the Netherlands, manure sensing is absolutely key. You know, what you're putting on the field, what nutrient you're actually applying through either farmyard manures or digestates, etc. They're absolutely looking at that to the nth degree. So there are definitely some hotspots. I think with the US, again, there are hotspots that are really developed, but again, a lot of it maybe not.
All the countries' agenda, you know, like policies, green agenda. So.
Probably more so, yeah. I think again there are some
legislation kind of driving it more than the actual requirements.
Yeah, and I think Germany, there's a lot more grants, and there seems to be more focus on anything that is supporting with, especially around nutrient management. So again, things like our NIR sensor, you know, doing the full picture of what we're taking off a forager, what we're reapplying through manures, to then what we're taking off a combine. There seems to be quite a high demand in NIR sensors in Germany.
Do you find there's a correlation between the electrification kind of things and site-specific stuff in terms of trying to apply that to customers? And obviously the electrification isn't there yet, but do you have much interest in that from the same kind of people?
Yeah, so if you talk UK specifically, there are some people southeast, you know, a lot of high value, whether that be fruits, high value crops, that they want all of the precision part and they want electrification. That's absolutely on the radar. Out in East Anglia, a lot of the veg type people are looking at, again, electrification. They want that. You know, they've got a lot of these big veg processing, they've got huge energy bills. They're looking for an element of greening that battery power might help with that.
I see that going in hand in glove with automation.
Yes.
A serious amount of electrification and precision.
Yep. Yep. Absolutely. Yep. Yep.
something about contract.
Yep.
I'm not sure if that's effective with the value in traditional use of it. I was talking about that values of operations you're talking about, not necessarily as like that.
It's capable, but it's where the duty cycle then becomes, you may be limiting your working window. So it does fit better with a lighter duty.
Quite prevalent all the way through. Are you seeing total duty cycles like 20 years ago to where we are today that massively changing? It's still where they were, but now the technology's got to catch up.
I think they are going up. I think again, maybe we're part of the problem with that. Agflation. Lots of farmers used to have many tractors. Now they may have fewer, working them longer, harder, bigger. So yeah, in years gone by, 750 hours a year was probably a norm. Now, if they're not doing 1,500 hours, then you're not getting the use out of them.
Where is a lot of the research and development on the electric car?
It's all over. So our European Engineering Centre is in Mannheim, Germany. So I would say that's probably been the centre for electrification right now. Because if you look at the simplicity of it, to try and tackle the elephant of getting a Waterloo 7, 8, 9 series tractor into battery is probably not your priority, but something in a Mannheim size where we've got from 90 to 200, that's where probably the sweet spot would be. So most of it would be in Germany, now and a bit in Austria with our new acquisition, of course.
Do you think this kind of seed and spray you have sort of modular kit on, so you could put it on any sprayer? Because you've got quite a barrier to entry if you want people to run out and buy another sprayer or a new sprayer just to have a saving here and there.
Yeah, it could well be. Today, if you've got a sprayer that is fully equipped with individual nozzle control, then actually adding see and spray shouldn't be a great deal of complexity, in theory.
Can you add it to one that had it might not be quite as accurate, save a bit of money.
You might save a bit of money, but you might find that your investment in the C part of that, you don't see the return. So.
Going to swarms of machines on property. With your smaller vehicles being your electric, do you see more going into that, or so your 8, 9?
Good question. Personally, I think there's going to be a requirement for both. Maybe we'll get onto another slide in a moment, but there's definitely a requirement for both. The small vehicles do offer benefit, and especially even in some of the horticultural high value salad, whatever, where they've been very labor intensive. There's a high volume of work to be done. You might find a swarm of vehicles actually is the solution to that. But I mean, we'll talk a bit about autonomy next, and right now, there potentially is a bit of a skill shortage, even on large scale farming, where actually you've got repetitive work that you have to do in a very short window. And maybe, the largest of our tractors being fully autonomous is pretty slick. I would say we've just seen that start to cap off. So some of you will know we've introduced 2 years ago our 8RX. So that's our 8 Series, which 4-track vehicle. So we do the 9RX bigger, and we've actually started to see people come down a model. You know, people that have had quad tracks and whatnot, they've actually just come down a size.
Are they coming down a size and having another bit?
Not necessarily.
Coming down a size and using, like, getting more out of less.
Getting more out of less, yeah. Being a little bit more flexible. Again, maybe, you know, the farming mix has changed, that, you know, a bit of min-till's gone into there as, or direct drilling has gone into the mix, so that maybe they don't have to work quite as hard. So that's, I would say, a trend that we've seen.
As a single brand, vulnerable with a single machine doing an awful lot of work, being 3 times what 3 tracks.
So hence you build stuff into the transmissions that make them more reliable and more durable and longer duty cycle. So, next question then, autonomy. So when I started 20 years ago, 22 years ago, we started showing this little tractor on everything. It was everywhere. Some of you may have seen that picture before. And actually that vehicle has been around so long, it's now in the John Deere Museum in Waterloo. So, you know, autonomy is not new, and refining it and getting it to where it needs to be has been the tricky part. And, you know, today, you know, you maybe have seen this, probably, what was it, just before Christmas last year, about November time frame, we showed off our fully autonomous 8R tractor, and that is available in the US. You can't actually buy it, but you can rent it from us. So again, it's still going through lots of learning, AI, you know, learning from what it will do. But as a customer, if you really wanted to, you could take one of them directly from us. And again, it goes to that point of, in the US today, there is an awful lot of corn, there is an awful lot of soybean, and generally they do the same jobs day in, day out, in a very short window now to prepare for the next crop. So this fits perfectly well into that mold. You know, how to work? It basically takes a standard tractor. We're not shy of the fact that we buy expertise into our business. So probably about 4 years ago, we bought a company called Bear Flag, and Bear Flag is a autonomous robotics company. So they helped us along with this. You know, we've been through lots of versions of what you might need as technology on a vehicle. Today, this has got 6 pairs of stereo cameras mounted around it to see where it is. Yeah, once you've mapped the field, you press go and it sets off. It's programmed to see so much stuff, and it will drive over it. If it sees something that it doesn't recognize, then it stops. It pings the farm manager. It sends him a picture and says, "Can I drive over this?" The guy says yes, and he drive, and the vehicle will drive over it. So yeah. So again, exciting times really, because we've got customers that say, can I get one? Quite when they will be really available within Europe, I guess many of you will know better than me as far as any sort of legislation or precedents that in law that need to be put in place to actually really allow these to fully function right now is pretty interesting. So, and then maybe to your point, whoever asked that, you know, what do we see as the size? Well, again, once you've got an autonomous vehicle, depending what power source you want to put in it, you know, this thing we've shown, it could be battery, it could be diesel, it could be whatever. it could be scalable at any size once you figure out how to do it. So yeah, those types of tools from us are on test. They're running around somewhere, and they're doing their thing. Quite interestingly, I don't know if anybody went to Agritechnica in 2019. It was the first time that John Deere actually put all of its wares, let's say, out on the table. So we had a future technology zone. So we had everything there, from drones to this. We actually had that tractor there, all sorts of different things. So again, it's an interesting time for the company that we are pushing the boundary of where some of this technology is going, and to get it to the market as quickly as we can. And then I think it's my final slide, is it? No, let's get that one. Oh, that one. So you said about a vehicle that might be the weight of it for battery. This could be a fully battery vehicle, but of course, potentially its envelope is pretty big. So fully autonomous battery. I don't know what the weight of that is. It's about, you'll see in a second, it's higher than the cab.
Focus on those is hours, isn't it? How many hours it's out there?
Yeah.
Stay all night.
Yeah, it's a fair monster. But again, I've got probably another video somewhere I can probably show you. We've also done we've got test units going out where they're actually tethered. So they will actually have a kilometre long extension lead effectively.
Yeah, that's still a serious proposition. And that just struck me as being very serious.
I don't think it is serious, but it's an option. It could be for somebody in a.
In terms of the autonomous stuff like that going forward, are John Deere working with any other companies, like shares in them companies, for example? I know. People, can we just have a bit of quiet? Because I'm struggling to hear the question. Thank you. For example, some of the other companies are putting shares into IAgrE, for example, and stuff like that. Are John Deere also doing that, or are you sticking to your own guns?
So at the moment, you can see we've got some of these things well on development already. So the IAgrE thing is a good example. It would probably match very similar to that one vehicle that we've got. So I don't think we're partnering with anybody like that, but what we are partnering with, we have got a startup program. So startup companies we're working with them. Bear Flag would be one of them. Kreisel is still a relatively new company. There's a few others that are specialists in these, either automation, robotics, whatever it might be. So it's definitely experience and knowledge, and the flexibility of a startup that we're buying into. So we are working with other companies, I guess, in the long and short term.
I think I've been right in what you've shown us, saying that what you haven't done is put all your eggs in one basket and say this is what's going to be. You've actually got potentially different solutions for different sectors of the industry, different sizes. Some of those will never have got past the computer screen stage. Some of them have actually turned into real prototype machines, which are running around for evaluation.
Yep.
So some of them may never be commercialized.
Yep.
Out of that broad range of things you are doing, and hopefully some will hit the market and be available for people to buy.
Absolutely. Yep. And again, you know, today, diesel is still relatively cheap in the grand scale of things. It's a great power source for, you know, power density from what we get from it. we will have, you know, legislative pressures that will drive us in different directions, but we also have a commercial driver in that we have to be able to offer a value to our customers in what they do. And so, you know, all those things, you know, we have to have things in the background ready, but, you know, we are not, I don't think, going to see a massive shift in the very near or short term to anything very different to what we may have today. If anything, the fastest shift you will see is where potentially there might be more of a biofuel type scenario, but that again will depend on where legislation is and government focus on where energy crops should or shouldn't be. So yeah, so no, it's interesting.
Can I ask, with your partnership with price and ownership, so are you also investigating the capabilities of battery electric on farm to help grid stabilisation?
Good question.
1,000 kilowatt hour pack there.
Yeah.
When it's set in the barn, it's peak shade.
It should. I was at a farm last week that they were doing that, and there's some big returns for that.
Yeah, that's money for the farmer.
That is money for the farmer. So I was on a group 5-6 years ago. The NFU ran a research project for vehicle to grid, and we were talking about that. I think going forward, that has to be put into the mix. You know, these large battery vehicles will have to be put into the energy solution that we have. So it makes perfect sense to do that.
Be a community thing as well. Power villages.
Yep. Except in the summer when they're all needed. That's, you know, we're working really hard. You know, and again, that's, I guess, the complexity of it. So. In what? Could be. I'm not close enough to know, but you would think that you would want to be saving every little watt you could possibly can. Yeah. Do they, I'm not sure. Right.
On the marketing side of bringing these to the market, what sort of, I mean, you talk about something you've got really early adopters.
Yep.
What percentage does that stand for? Is that like got really early adopters, but there's 3 of them, and all the others are looking at you, waiting for somebody else to move, or waiting for some legislation to actually force them to go that direction? Are you getting pulled in a way that your business would want it, or are you still disappointed with, obviously you invested huge amounts, are you getting the yield, if you like?
Yes, I think we are. I think the last few years we've seen this step change, and that comes down to even our dealer network and the expertise that we have. You know, being able to advise customers to the right decisions has all been part of it. You know, this is where, again, you know, almost to the journalist part, it's easy to talk about the nuts and bolts, but talking about the total solution that's available, you know, I think that's where we would hope that we've got cleverer with our dealers, our sales professionals, our precision ag specialists, you know, the tools that they're using to be able to offer a greater solution to a customer. You can't just black and white, well, this is just your prime mover, or this is just your, you know, you've got to join all the dots.
Generational thing.
No, yes and no. I think there are older generations that want it and get it, and you know they're inquisitive to know about it. And there's younger people that are not, but I wouldn't say it's a generation thing, but it's people that are wanting that maybe it's the whole Kubler-Ross change, whatever. You know, you don't want to if you're against change, then you're not necessarily going to want to adopt. So.
Yeah, I was just thinking from your point of view, you all know, how hard is it to get the message across in a language that people understand?
I think so for me, one of our big things, and again, I might have done a bad thing here as well. You know, it's always nice to see what's just coming and what's the future, but the most important bit is, what can I do today? You know, I can see this fully autonomous tractor, but actually, what do I need to do today to get there? If that's my end game, how do I get there? And for a farmer, that might be, right, okay, well, you need something with an element of precision farming on. You need a receiver, you need a display, you need to map the fields. Once you've got those all logged in the operation center, then when that comes, you know, that's one step. Then you can go to your next step and whatever else. So I think there's been a lot, again, even in the press, where we talk about the reaching the moon, but we don't want to reach the moon. We need to make the small steps to how we get there. And what's the value of that? You know, if I spend, let's pick this one up. If I spend $3,000 on a receiver, if that's what it is, you know, what's my payback? What's my return? If you can show it's going to actually save you £50 a hectare, whatever, then it's easy maths. So.
And what time frame is we're obviously not going to pitch these just yet. So yeah, you guys must be doing the next emissions legislation, Euro 6 equivalent, like trucks got. There must be something like that coming tonight. So you're going to be developing that diesel.
Yep.
On all of it and everything, or you just going to focus on a certain area?
Again, I don't think you're going to see a clear break on any particular size. I think we're going to continue as we are with options in certain sectors. So,
but you foresee that we're not going to do that. So I don't know, 40 horsepower anymore now, because we're going to go electric on that.
That's probably, you're going to start at the bottom and work up, I would imagine. That could well be the case, yeah. But start at the bottom. Yeah.
I know a lot of your research and development is done all around the world, but if there is anything going on in the UK, would there be an opportunity to have some students out and have a look, or
don't be silly.
Bring it to depending on how top secret it is. It'd be nice to have some machinery, green stuff outside for the students to go have a look at, depending on what we're allowed to see.
Yeah.
Whether that's an option or not.
We generally don't put people in front of test machines. They're pretty well hidden and they're badged as other stuff and all sorts. So I'd like to say yes, but sorry, I doubt it somehow.
What about that? So the IAgrE with that Joskin slow tanker on the electric drive, would there be an opportunity for something like that?
Yeah, no. So that landed with us, and we're doing a bit of a demo tour, and we do actually want to get that. Yeah, that would be a good thing for us to do. Yeah.
Just going to take you back to you've got it there now. Yield mapping.
Yep.
At the start of the student farm, we had these things being going on over taking soil samples.
Yep.
I'm reckoning that you know enough about what you're taking off the surface, and you know what you're putting on the surface in terms of agricultural and fertilizer. You probably use machine learning to deduce what's going on below ground. There's no need to take soil samples.
It might be, again, you'll need a calibration that you might need to do it somewhere along the line just to make sure that for your soil type, that's roughly where it is. So I think, again, this site-specific farming, it will use different forms of data to add in. So whether that be, you know, measuring the protein of what you're taking off, having an input of what the soil may be, you know, whether it be cameras with drones, all of that, you know, all of these things are going to put into, you know, part of the decision making, and that should really influence what you do. So I think soil's our greatest asset right now. we need to make sure we look after it and understand it and not abuse it with what we put on it.